Download this code from codegive.com, link in the description below. Augmented reality, AR, no BS tutorial with code examples. This tutorial dives into augmented reality, AR, development without the fluff. We'll focus on practical implementation, using libraries and frameworks that get you results quickly. We'll be using arkit, iOS, and arcore, Android, as they are native and offer the best performance, but also show you how to use webar, three.js plus ar.js, for cross-platform browser-based AR. Disclaimer *: this is a beginner-friendly guide, but some programming experience is recommended. We will assume basic knowledge of either Swift/Objective-C, for arkit, Java/Kotlin, for arcore, or JavaScript, for webar. Topics covered *: 1. AR concepts, what you need to know. 2. arkit, iOS basics, plane detection, anchor placement, and virtual content rendering. 3. arcore, Android similar concepts as arkit, but on the Android platform. 4. webar, 3.js plus ar.js cross-platform AR in the browser. 5. Advanced topics, brief overview, scene understanding, image recognition, cloud anchors, and performance optimization. 6. Troubleshooting and common issues. 7. Resources and next steps. 1. AR concepts, what you need to know. * What is augmented reality? Overlaying computer-generated content onto the real world through a device, smartphone, tablet, AR glasses. * Key components * tracking * determining the device's position and orientation in 3D space. This is typically done using sensor fusion, camera, accelerometer, gyroscope. ARKit and arcore offer robust tracking capabilities. * Scene understanding * analyzing the environment to identify surfaces, objects, and lighting conditions. This allows for realistic placement and interaction of virtual content. Also known as environmental understanding. * rendering * drawing the virtual content onto the screen, integrating it seamlessly with the camera's video feed. Requires a rendering engine, example SceneKit for arkit, SceneForm or OpenGL for arcore, 3.js for webar. * coordinate systems * crucial for AR. Understand how the real world is mapped to a virtual coordinate system. ARKit/arcore handle the heavy lifting, but knowing the basics helps. Typically, you will see the origin, 0,0,0, being where the AR session started. * anchor points * fixed points in the real world that are used to attach virtual objects. These could be detected planes, surfaces, images, or manually placed points. Anchors help keep your virtual content aligned with the real world as the device moves. * hit testing * determining what part of the real world the user is tapping on, or pointing at, on the screen. This allows users to interact with the virtual environment. 2. ARKit, iOS, tutorial. Prerequisites *. Xcode, latest version. * an iOS device with A9 processor or later, iPhone 6s or newer. * basic understanding of Swift or Objective-C. Step 1. Create a new arkit project. 1. Open Xcode and create a new project. 2. Choose Augmented Reality app as the template. 3. Enter your project name, organization identifier, and select Swift as the language. 4. Make sure content technology is set to SceneKit or Metal. SceneKit is easier for beginners. Step 2. Configure the viewController.swift file. Explanation *. *ARSC and view delegate *. This protocol allows you to respond to arkit events, such as the detection of planes. *AR world tracking configuration *. This configuration enables world tracking, which allows arkit to understand the device's position and orientation relative to the real world. Plane detection equals horizontal tells arkit to look for horizontal surfaces. *renderer _did add for *. This delegate method is called when arkit detects a new anchor, in this case, a plane. It creates a SCN plane, a rectangular shape, positions it correctly, and adds it to the scene. *renderer _did update for *. This delegate method is called when an existing anchor is updated, example the plane's dimensions change. It updates the SCN plane's width, height, and position. *plane visualization *. The code creates a semi-transparent white plane that visually represents the detected surface. This is helpful for debugging and demonstration purposes. Step 3. Add an object on tap. 1. Add a tap gesture recognizer to the scene view. Explanation *UI tap gesture recognizer detects tap gestures on the screen. *hitist _types determines if the tap intersects with any existing planes. The types existing plane using extent option ensures that the hit test is performed against the detected planes. *hitist result world transform columns point 3 * gives us the position of the hit point in world coordinates. Creating and adding the sphere the code creates a red sphere, positions it at the hit point, and adds it to the scene. Note that the Y position is slightly adjusted by adding the radius to make sure the sphere sits on top of the plane, rather than being half submerged. Step 4. Build and run. Connect your iPhone/iPad to your computer, select your device in Xcode, and click the Run button. Point your device at a flat surface. You should see the semi-transparent planes being detected. Tap on a plane to place a red sphere. 3. Arcore, Android, Tutorial. Prerequisites *. Android Studio, latest version. * an Arkore supported Android device. * basic understanding of Java or Kotlin. Step 1. Create a new Arkore project. 1. Open Android Studio and create a new project. 2. Choose empty activity as the template. 3. Give your project a name, package name, etc. 4. Add the Arkore dependency to your build.gradle module, app, file. 5. Add Arkore metadata to your Android manifest.xml file inside the application tag. 6. Add required permissions in Android manifest.xml outside the application tag. Step 2. Create an AR activity.java, or Kotlin equivalent. This activity will handle the Arkore session. Explanation **** GL surface view and renderer **Arkore uses OpenGL for rendering. The GL surface view provides a surface for OpenGL to draw on, and the renderer interface defines the methods for drawing each frame. **session *** The core Arkore class manages the AR session, tracking, and scene understanding. *config configures the Arkore session. Config.setPlaneFinding mode, config.planeFindingMode.horizontal, enables plane detection. *frame represents a single frame of camera data. Used to access camera images, detected planes, and other AR data. *hit result the result of a hit test. Contains information about the intersection point between array and the real world. *renderers *background renderer, plane renderer, point cloud renderer and object renderer are classes that handle the OpenGL rendering of the camera feed, detected planes, point cloud, and the virtual object, and the Android in this example, respectively. You'll need to create these classes separately. Example content for those renderers, written in OpenGL Java / background renderer.java package com example.myarkareep import android.content.context import android.graphics.bitmap import android.graphics.bitmap factory import android.opengl.gles20 import android.opengl.glutils import android.utility-log import java.io.io exception import java.io.input stream import java.neo.byte buffer import java.neo.byte order import java.neo.float buffer public class background renderer private static final string tag equals background renderer.class.get simple name private static final int coords underscore per underscore vertex equals 3 private static final int text coords underscore per underscore vertex equals 2 private static final int float underscore size equals 4 private float buffer quad coords private float buffer quad text coords private static final string vertex underscore shader underscore name equals shaders / screen quad dot vert private static final string fragment underscore shader underscore name equals shaders / screen quad dot frag private int quad program private int quad position param private int quad text coord param private int texture id equals -1 private int texture uniform public int get texture id return texture id / asterisk allocates and initializes OpenGL resources needed for rendering the background. Must be called. Asterisk on the OpenGL thread, typically in at link GL surface view.renderer and surface created, GL10. Asterisk EGL config. Asterisk. Asterisk at param context needed to access the shader source code. Asterisk / public void create on GL thread, context throws IO exception. Quad program equals shader util.load GL shader, context, gles20.gl underscore vertex underscore shader, vertex underscore shader underscore name. Int fragment shader equals shader util.load GL shader, context, gles20.gl underscore fragment underscore shader, fragment underscore shader underscore name. Quad program equals gles20.gl create program. gles20.gl attach shader, quad program. gles20.gl attach shader, quad program, fragment shader. gles20.gl link program, quad program. gles20.gl use program, quad program. Shader util.check GL error, program creation. Quad position param equals gles20.gl get attrib location, quad program, a underscore position. Quad text coord param equals gles20.gl get attrib location, quad program, a underscore text coord. Texture uniform equals gles20.gl get uniform location, quad program, u underscore camera texture. Shader util.check GL error, program parameters. / note, the quad coordinates are set to align with the far clip plane of the AR camera. / this, combined with depth testing disabled, ensures that the far clip plane will / always be rendered behind the AR content. Float keywords equals. New float. Dash 1.0 f, dash 1.0 f, 0.0 f, dash 1.0 f, plus 1.0 f, 0.0 f, plus 1.0 f, dash 1.0 f, 0.0 f, plus 1.0 f, plus 1.0 f, 0.0 f. Float text keywords equals. New float. 0.0 f, 1.0 f, 0.0 f, 0.0 f, 1.0 f, 1.0 f, 1.0 f, 0.0 f. Byte buffer bb keywords equals byte buffer dot allocate direct, keywords dot length asterisk float underscore size. bb keywords dot order, byte order dot native order. Quad keywords equals bb keywords dot as float buffer. Quad keywords dot put, keywords. Quad keywords dot position, 0. Byte buffer bb text keywords equals byte buffer dot allocate direct, text keywords dot length asterisk float underscore size. bb text keywords dot order, byte order dot native order. Quad text keywords equals bb text keywords dot as float buffer. Quad text keywords dot put, text keywords. Quad text keywords dot position, 0. Int textures equals new int 1. gles20.gl gen textures, 1, textures, 0. Texture id equals textures 0. gles20.gl bind texture, gles20.gl underscore texture underscore 2d, texture id. gles20.gl text parametry, gles20.gl underscore texture underscore 2d, gles20.gl underscore texture underscore min underscore filter, gles20.gl underscore linear. gles20.gl text parametry, gles20.gl underscore texture underscore 2d, gles20.gl underscore texture underscore mag underscore filter, gles20.gl underscore linear. Shader util.check gl error, texture loading. / load a placeholder texture. Bitmap texture bitmap equals bitmap factory.decode resource, context.get resources, r.drawable.placeholder. glutils.text image 2d, gles20.gl underscore texture underscore 2d, 0, texture bitmap, 0. Texture bitmap.recycle. Shader util.check gl error, placeholder texture loading. gles20.gl bind texture, gles20.gl underscore texture underscore 2d, 0, / unbind the texture. / asterisk draws the AR background. Must be called on the OpenGL thread. Asterisk. Asterisk at param frame the current AR frame. Asterisk / public void draw, frame. If, texture ID equals -1. Return, / not initialized. / ensure that the texture is updated. Frame.acquire camera image, .close. gles20.gl depth mask, false. gles20.gl use program, quad program. / attach the camera texture to the uniform. gles20.gl active texture, gles20.gl underscore texture 0. gles20.gl bind texture, gles20.gl underscore texture underscore 2d, texture id. gles20.gl uniform 1i, texture uniform, 0. / set the vertex positions. gles20.gl vertex attrib pointer. Quad position param, coords underscore per underscore vertex, gles20.gl underscore float, false, 0, quad keywords. gles20.gl enable vertex attrib array, quad position param. / set the texture coordinates. gles20.gl vertex attrib pointer. Quad text keyword param, text coords underscore per underscore vertex, gles20.gl underscore float, false, 0, quad text keywords. gles20.gl enable vertex attrib array, quad text keyword param. gles20.gl draw arrays, gles20.gl underscore triangle underscore strip, 0, 4. / disable vertex arrays. gles20.gl disable vertex attrib array, quad position param. gles20.gl disable vertex attrib array, quad text keyword param. gles20.gl depth mask, true. / point c loud renderer.java. Package com example.myarkareep. Import android.content.context. Import android.opengl.gles20. Import android.opengl.matrix. Import android.utility.log. Import com google.arcore.pointcloud. Import java.io.io exception. Import java.neo.byte-buffer. Import java.neo.byte-order. Import java.neo.float-buffer. Public class pointCloud renderer. Private static final string tag equals pointCloud renderer.class.get simple name. Private static final int bytes underscore per underscore float equals 4. Private static final int floats underscore per underscore point equals 4, / x, y, z, confidence. Private static final string vertex underscore shader underscore name equals shaders / point underscore cloud dot vert. Private static final string fragment underscore shader underscore name equals shaders / point underscore cloud dot frag. Private int vibo. Private int vibo size equals 0. Private int program name. Private int position attribute. Private int model view projection uniform. Private int color uniform. Private int point size uniform. Private int number points equals 0. / keep track of the last point cloud to avoid allocation every frame. Private point cloud last point cloud equals null. / asterisk allocates and initializes OpenGL resources needed for rendering the point cloud. Must be asterisk called on the OpenGL thread, typically in at link GL surface view.renderer and surface created, GL10. Asterisk EGL config. Asterisk. Asterisk at param context needed to access the shader source code. Asterisk / public void create on GL thread, context, throws IO exception. Shader util.check GL error, before create. Program name equals. Shader util.load GL shader, context, gles20.gl underscore vertex underscore shader, vertex underscore shader underscore name. Int fragment shader equals. Shader util.load GL shader, context, gles20.gl underscore fragment underscore shader, fragment underscore shader underscore name. Program name equals gles20.gl create program. gles20.gl attach shader, program name. gles20.gl attach shader, program name, fragment shader. gles20.gl link program name. gles20.gl use program name. Shader util.check GL error, program creation. Position attribute equals gles20.gl get attrib location, program name, a_position. Color uniform equals gles20.gl get uniform location, program name, u_color. Model view projection uniform equals gles20.gl get uniform location, program name, u_model view projection. Point size uniform equals gles20.gl get uniform location, program name, u_point size. Shader util.check gl error, program parameters. / create buffer objects to store the vertices. Int buffers equals new int 1. gles20.gl gen buffers, 1, buffers, 0. Vibo equals buffers 0. gles20.gl bind buffer, gles20.gl_array_buffer, Vibo. Vibo size equals 0. gles20.gl buffer data, gles20.gl_array_buffer, Vibo size, null, gles.